All right, today we are going to talk about um, hypothesis testing, but we will talk about hypothesis testing and then use two different softwares to do hypothesis testing. We're going to use SPSS and we're going to use MS Excel. Now, the purpose of using MS Excel is to show you the difference between using the two, and you feel free to use the two, any of the two softwares, the MS Excel or SPSS. But MS Excel is going to take you much longer and would involve you in many more calculations and taking a few more steps. But that's up to you. It's entirely up to you. All right. I provided you a link where you can download SPSS for $40. The course has been made into a zero textbook cost. And so the $40 is essentially the only amount of money you would spend in the class. And I believe that when you spend the $40, you can you can install it in two different computers. So two students can share one copy and install it in their two different computers. And so it comes to $20 each. Okay. I know the pandemic has put quite a bit of stress in people's finances, everybody, including professors. So I would hope that you will put your best into this class. Having said that, let's begin today. I'm going to pull up a PowerPoint slide, and I'm going to use that PowerPoint slide to make progress in the class, to move from one stage to another. Hypothesis testing is something that I expect that you did in ECON356, the first level statistics class. And so it's just a review we're going to do. Okay, so this is just a review. We are in the third week of the semester. And so we're just doing hypothesis testing. Today, we're going to do hypothesis testing for one population. And next, on Monday, we're going to do hypothesis testing for two populations. Now, we're not going to be holding 2 office hours a week. We're going to be holding 1 office hour on Monday, where we're going to do the lecture. And then on Thursday, I'm going to hold a general office hour where students that are not in this class will come in. And therefore, on Thursdays, the only thing you can do is to watch the video on Monday, the video that was done on Monday. And if you have more questions, then you can come in on Thursday and ask your question. Now, when you ask your question, once you get the answer to your question, you can leave. But we're not going to repeat Monday's lecture from the beginning. That will not happen. Okay, so having said that, I'm going to share my screen and begin to talk about hypothesis testing. And then we'll get into an illustration. So I'm going to be very quick in terms of discussing hypothesis testing. The key thing that we're going to do here really will be to illustrate how to use SPSS, and then illustrate how to do the same problem using MS Excel. Okay, guys, are you seeing my screen? Hello?
Yes, Professor, we can see the screen.
Okay, so you're seeing my screen. So, like I said, this week we're going to do hypothesis testing for one sample. And then next week, we're going to do hypothesis testing for 2 samples. These examples in hypothesis testing will be in the form of a review, because we have already done hypothesis testing in statistics 1. So we're now reviewing it, because in statistics 2, we're going to move into more advanced topics. Besides spending a little bit more time in hypothesis testing for 2 samples, much of statistics 2 will be really about regression analysis, and then we will introduce some index numbers. So let's move on. All right. So again, by the time we are done with this, we will define a hypothesis and explain the process of hypothesis testing, and then apply hypothesis testing in general form, and then we're going to do an interpretation of an SPSS output, and then we're going to demonstrate how you can do hypothesis testing using SPSS. Okay. I'm going to provide a simple example. I'm going to delete that example. Here's an example that I'm going to try to use. For example, we'll say a machine is expected to produce 595 units per day on the average. Okay. So what this simply means that if you operate a certain machine that produces shoes or produces eyeglasses, this particular machine is expected on the average to produce 595 units a day. And if the machine is producing 595 units per day, then it is doing its job. Okay, there are no problems. For example, so what you do is you take a sample of days, like 100 days, like 60 days or 70 days, whatever. You can take any number of samples, and every day you say, how much did this machine produce? So you take 60 days, and you calculate altogether how many were produced and the average number of, say, products or units that are produced on the average per day over the 60 days, and then you test the hypothesis. You say, all right, this machine is doing its job. Okay. And so how do we proceed then to test a hypothesis? The first step is to state what is called a null hypothesis and to state an alternate hypothesis. And once you state a null and an alternate hypothesis, then you will select a level of significance. Okay, that is to say, what is the probability that the conclusion is not correct? Okay, what is the probability that the conclusion is not correct? So that is what you call a level of significance. And that level of significance usually is a small percentage, like say 1% or 2% or 3% or maybe 5%. All right, it could be even less than 1%. It could be half of 1%. So that is your level of significance. Then you identify what is called the test statistic, which uses the normal distribution that we discussed last week. You identify a test statistic, and we're going to do that along the way. Then you formulate a decision rule. Okay, you formulate a decision rule. That decision rule we will also illustrate this example. And then based on the decision rule, you arrive at a decision and then interpret the results. Again, we're going to do an illustration to show this. All right. Now, when you say a null hypothesis states, for example, is like we said this machine on the average should produce 595 units a day. Another example of a hypothesis, the average travel time for a student at McGivers College to get to school is about 25 minutes. That is your null hypothesis. The alternate hypothesis will be the average travel time is not 25 minutes, or the average travel time is more than 25 minutes, or the average travel time is less than 25 minutes. That is your alternate hypothesis. You can have different alternate hypotheses based on one null hypothesis. The first one where I say the average travel time is not 25 minutes, okay? It means that the average travel time could be less, it could be more, but it's simply not 25. Now, we'll call that a two-sided hypothesis, and we're going to illustrate it. So we'll call that a two-sided hypothesis. Now, but if you say that the alternate hypothesis is that the average travel time is more than 25 minutes, you are saying, in effect, that what you have is a one-sided hypothesis. A one-sided hypothesis. If you say the alternate hypothesis is less than 25 minutes, that is also a one-sided hypothesis. All right? We've already talked about that. What is the probability that you're going to reject the null hypothesis? Okay. All right. Here is the example that I was talking about. All right. The example I was talking about. And the example here is about the expected performance of a machine. So a machine is designed to produce 595 units per day. All right. And in order to test this hypothesis, and we're going to actually go through the test of hypothesis using this information. Now, after we test the hypothesis that I just stated here, I'm now going to go through a process where we test the hypothesis using data from scratch. Now, the hypothesis that you're seeing here is not using data from scratch. A lot of the work has already been done, and you are given a summary of the data. Now, when you have this summary of the data, you can test a hypothesis using the summary. But what if you do not have this summary? What if you do not have this summary? You have data from scratch. And so we're also going to do an example where we have data from scratch.
His voice.
Hello. Welcome, Mr. Friends. All right. Okay, we're already, hello, we're already in the middle. And we're just going to continue. All right, so this is an example of hypothesis test. But in this example, you already have your summary, your statistical summary, but you still have to test the hypothesis, okay? All right, so how do we go about doing that? Okay, how we go about doing that is we have already collected the sample, all right? We have already collected the sample, and we have calculated the sample mean. So I'm going to repeat the process of hypothesis testing, okay? I'm going to call this the steps in hypothesis testing, okay? Collect a sample of size n, all right? The sample, let us a data sample, so that we know what we're talking about. Size n, calculate sample mean, okay? Sample mean is X bar, so all right. So we'll collect the sample mean X bar. And then we'll calculate the sample standard deviation, okay, S, all right? And then we state level of significance, okay, alpha, and the level of significance is alpha. For example, right, 2%, 0.02, or 1%, 0.01, or anything, okay? These are examples. And then select the test statistic, which we'll call Z star or T star. All right. So these are the steps. Then you state decision rule. All right. The decision rule. Okay. Which means we have to calculate Z, and if Z is greater than or equal to Z star, we reject the null hypothesis. All right. Okay. So these are the very simple steps. Okay. And of course, after you reject or not reject the null hypothesis, then you make a decision. Since that you interpret. So we're going to go through these steps for this simple problem. Now, does anybody have any questions? Hello? Any questions so far?
No.
No, not yet. Okay, fine and good. All right. So now, for the example that I showed you out there, we've already gone through the first step. Okay, we've already gone through step one. We've collected some data of sample size n, and we said that that n in that example was what? Was 38, okay? So the example that size n, example 38, okay? That's what we have, n equals 38, okay? Okay, our example was n equals 38, and we already calculated the sample mean. Example, X bar in our example. What was the example there? Sample mean was 625. All right. And we calculated the standard deviation. Okay, our sample mean was 65.5. Okay, 65.55. All right. And we selected a level of significance of 0.01. All right. So now, what is the test statistic? We're going to use Z star because we have a large sample size, and Z star is 1. All right. I believe that in statistics 1, you learn how to select the Z star. We can go back through it, but for significance of 0.01, Z star is 2.33. Okay. I know somebody's going to ask, how did you get that? Okay. I think we did that in statistics 1. We also did that last week, the last office hour we had. So I suggest you watch that video and learn how to calculate Z star or how to identify Z star. So now we are going to get where we actually calculate Z. I'm going to make that a step by itself, the calculation of Z. Okay, so we're going to calculate Z. So how do we calculate Z? Z is equal to, and I'm going to create an equation here. Z is equal to X bar minus the null hypothesis divided by S divided by all right. So that's what we have. That is how to calculate Z. And once you calculate Z, you use you make a decision rule, okay? And the decision rule that if Z is greater than Z star, you reject the null hypothesis. And what does that mean? Okay, what does that mean? We're going to go through that process immediately and say, this is what that means, okay? So I'm going to take that. Let's go through the process. Okay. Use of hypothesis. We already know that X bar okay. We already calculated that X bar was 625. That is what we calculated. And S, the sample standard deviation, was 65.55. Okay. Know that N is equal to 38. All right. And also we took Z star equal to 2.33. So what is Z? Okay. This is the formula for Z. Now, before we go through that, we have to state the null hypothesis. Okay. Okay. The null hypothesis is that the average, and the average is mu, hypothesis for mu, and I'm going to hypothesis for mu equals, so the null hypothesis is that the average mu is the population average. So our hypothesis is that mu average is equal to 595. The machine produces on average 595 units per day. That is the null hypothesis. All right. I'm going to see if we can fit that. That's our null hypothesis. The alternate hypothesis is that the alternate hypothesis HA is that mu is greater than 595. Okay. The machine produces more than 595 units per day. This is the alternate hypothesis. So to test that hypothesis, we collected data, a sample of 38 days of data. And then for those 38 days, we obtained a sample mean average output of 625 with a standard deviation of 65.55. All right. And we're going to test the hypothesis at a significance level of 0.01. So we calculated and we identified the critical Z value. This is the critical Z value of 2.33. So now we calculate Z. Z is X bar minus the null hypothesis divided by S over root N, which is easy to calculate. So I need for you to help me out now. X bar we know is 625. The null hypothesis we know is 595. And S is 65.55. And N is 38. So what do we have? Can somebody help me? Hello, guys. Hello, people.
Try to figure it out.
Okay. So I'm waiting for you.
Professor, 2.81?
All
No,
right,
2.82.
It's 2.82.
2.82, that's what you got.
Yeah, that's what I got.
All right. Anybody else got the same answer?
Yes, it's 2.82.
Okay. All right, 2.821. Okay, fine. 2.82. So that is our answer. So Z is 2.82. So decision rule, if Z 2.821 is greater than or equal to, and I'm going to go and look for that information. .33, which is Z star. What do? We reject the null hypothesis. Okay. All right. So now, given this information, what is your conclusion? Do you reject the null hypothesis or do you not? Hello, guys. Somebody help me.
Can you repeat that, Professor?
What is your decision? We have set a decision rule that if Z is greater than Z star, we reject the null hypothesis. We calculated Z to be 2.821. And we say if Z is greater than Z star, we reject the null hypothesis. What is your decision? Do you reject the null hypothesis or do you not reject it?
You reject it?
So you reject the null hypothesis, am I correct? All right?
Yeah.
Correct.
So you are rejecting the null hypothesis that the machine produces an average of 595. So what is your conclusion then? Do you then accept the alternate hypothesis that the machine does what? What is your conclusion?
That they produce more.
They produce more, that's it.
Is that they produce more than 595 units.
The machine produces more than 595 units. So this machine is doing its job. Because if the machine is producing in excess of 595, then the machine is doing its job. That is the conclusion. That is a simple test of hypothesis. But what has happened here is that you have been provided all the information. You have been provided the summary statistics. What if not? What if not? What if you were not provided the summary statistics? How would you proceed? All right. So we're going to look at an example where we are not provided the summary statistics. All right. Okay, so this is our example. There's evidence that the average daily output is in excess. You see that? So that is our conclusion. So we're now going to look at an example where the you are given raw data. Okay, we're going to do an example with raw data, and I'm going to start that problem from scratch. Okay. Okay, so you test from, I'm going to use simple language here, from scratch. Okay. Okay, so we're going to use SPSS to do the problem. Okay. So the first step is read the SPSS data. We're going to look at a data view. Okay. We're going to look at a variable view with labels, variable labels, and value labels. Okay. Then we're going to look at procedures, which is analyze procedures. Okay. The procedures are based on what we call analyze. Okay. All right. So I'm going to save this, and then I'm going to pull up an SPS. I'm going to pull up an SPS file. Okay. So let's stop this share and pull up an SPSS file. All right. Are you seeing my SPSS file?
Yes, Professor.
All right. All right. So this SPSS file is in data view. What is the SPSS file about? Okay. What is the SPSS file about? The SPSS file I'm trying to take off things that you do not need. The SPSS file has data on houses. Data on houses. The first variable here is the price of these houses in a neighborhood. The second variable, size, shows the size of the house in terms of living space. The other variable is lot size, which is what is the size of the land on which the house was built. Then here you have the year the house was built. Okay, all these houses were sold in 2009. So now this is the price per square foot, which is easy to calculate. If you look at the size of the house and look at the price, if you divide price by size, you will get price per square foot. This is the age of the house at the time it was sold, which case, like I said, the houses were sold in 2009. And so if you subtract 1965 from 2009, you're going to get 44, all right? And this variable called type is the type of house. Is it a one-family house or a two-family house? Okay, is it a one-family house or a two-family house? And you have about 93 houses altogether, 92 houses. So now the question is, how do you use this to test a hypothesis? Okay. What will be our hypothesis? Okay. What will be our hypothesis? I'm going to test a hypothesis right now. Okay. Now, before I go and test the hypothesis, I'm going to stop sharing this and state a hypothesis. I will state a hypothesis and say, in these neighborhoods where we identify these houses, wherever these houses are from, I will state a hypothesis to say that the average price of houses in this neighborhood is about, say, $450,000 or more than $450,000. I will state that hypothesis. And then we will test the hypothesis. So I'm going to stop share, and then we're going to say the hypothesis, and then we will come back and run this SPSS to show you how we can test the hypothesis using SPSS. Okay, so I'm going to have you actually know how to use software. So the last time I told a story, and I would like for you to hear that story again if you already heard the story. And if you have not heard it, to make some sense out of it, okay? To make some sense out of it. Here is the story. Okay, here is the story. There was a story about many years ago, the 1930s. 1930s, many of our grandmothers and our mothers were not yet born. In those days, in the 1930s, you could buy a car with about $500. $500. Okay. So there was a power outage like you have in Texas today. And after 4 days, nobody could fix it. And so the mayor was about to lose his job. The electric company was about to lose their monopoly. So the company called out an engineer who was retired and asked him to help. So he went to the electric plant and he turned on the switches and he said, everybody come with me. So everybody went with him. And he went to this corner of the plant and he tightened this little knot and he tapped on it and he turned on the switches and all the light came back. So he said, what is your bill? And he said, $5,000. I said, $5,000? You could buy 10 cars with $5,000, my friend. So can you give us an itemized bill? And he said, okay. For tapping on that little spot, which they complained about, you tap on that little spot and you ask us to pay $5,000 for that? That's not a lot of work. He said, for sure. For tapping on that little spot, $1. For knowing where to tap, $4,999. So what I am trying to get you all to understand and why we are going through all of this is that you will know where to tap. And you will make $4,999. Even for today, that's a lot of money for just knowing where to tap. Okay, so having said that, let's go through our process again. All right, so we're going to test a hypothesis. Okay. So when we've looked at SPSS, we looked at the data view. We have not looked at the variable view. Okay. We're going to go back to it. hypothesis on average price of houses.
So are you showing your screen or are you working?
Oh, thank you so much. Thank you so much.
You're welcome.
This is what it takes to be present. All right. I'm going to share my screen. All right. So, hypothesis testing, average price of houses. Okay. SPSS example. All right. So this is what we're going to do. So we're going to pull up the SPSS data. Okay. And the data, then I'm going to share the SPSS file once more. So now we are in the variable view. In the variable view, you have the price, which is called price, this sold price of the house, the date the house was sold, what have you. Okay. Then we have the value levels. Okay. No, this is not what we're looking for. We're looking at, this is what we're looking at. The price of houses, the size of houses, the lot. This is housing by family size. Okay. So how do we go through the process? We're going to calculate the mean. Okay. We're going to calculate the mean. We're going to calculate the standard deviation. We're going to calculate the Z value. And we're going to test the hypothesis. So SPSS will give you everything. Okay. How do you do analysis using SPSS? The first step is to analyze. You say analyze. And then you compare means. All right. Because we are testing just one variable, we're not differentiating between one group and another. We say one sample t-test. We click on it, one sample t-test, and we are testing the price at which house is sold. Our null hypothesis is that the houses sell for more than $450,000. So we put in the test value of 450,000. Okay. We're going to test at 99% confidence interval, which is alpha is 0.005. Okay, and ask me questions after that. And so, what do we have? All right. So here is our example. So I'm going to take this example and paste it into our PowerPoint. Okay, so I'm going to stop sharing this for a minute and paste this example into PowerPoint. So now, do you see what has happened here? Okay. The test value is 450,000. Okay. So now SPSS has done all the work for you. So I'm going to take that. I'll cut it. And I'll edit it to make it easy for you to understand. Just bear with me for a minute. You're just going to see the results. Okay, so you see my new screen? Hello? Hello, guys.
Yes, Professor.
Okay, let me hear something because I don't want to lose you. Okay, so now after doing the SPSS run, this is what we see. Okay. Okay. So we see a screen. This is too messy. Okay, are you able to see the screen?
Yes.
Are you able to see the numbers?
Yes.
Okay. All right. So now what do you see? What you see is you see your Z value. Let's call that Z. Okay. You see your Z value is 8.831. So now if you were to do a test of hypothesis, where is my stuff? Okay. So if you were to do a test of hypothesis, what would you do? you have a Z value of 0.831, am I correct? Okay. And your hypothesis testing, I'm going to hypothesis testing for house problem. Okay. What was the null hypothesis? The null hypothesis, H0, was that sorry guys,
No problem, sir.
Okay, Professor.
I was at the location. I'm at a location where the internet has been unstable.
Okay.
I hope I didn't lose anything. Okay. The hypothesis was that mu is equal to 450,000. That was a hypothesis, a null hypothesis. The alternate hypothesis is that mu is greater than 450,000. All right. So the average price of houses is about 450,000 or less. The average price of houses is greater than, say, higher than $50,000. Okay. Level of significance about 0.005 means that Z star was a 2.576. Okay. So now we calculate Z to be equal to 0.831. This is what you saw from that table. Am I correct?
Yes.
All right. I'm going to take off what is not useful for you. Okay. So based on this, you see that Z is 0.831. Am I correct? And so you put it here, Z is 0.831. And so the decision rule if Z, which is 0.831, is greater than or equal to Z star 2.576, you reject the null hypothesis. All right. So now, based on your calculation, would you reject or not reject the null hypothesis?
In his class for the fall semester?
Yeah.
Okay, me too. I was in that class as well. I'm trying to have a couple of assignments I'm trying to catch up on because everything's moving so fast.
Okay, okay, all right.
Oh, hi,
So,
Professor. Yes. Welcome
So
back.
I am sorry. Let's go through this, and I would have to repeat part of this lecture on Monday because this internet here is because of the weather. That's what's going on. Because of the weather, it's raining so bad where I am, and so the weather is just cutting off the internet. In any event, okay. Oh, I was in the middle of something. So let's bring it back up. Okay. So based on this Z value, would you reject or not reject the null hypothesis? Hello, guys. Based on the Z value of 0.831, would you reject or not reject the null hypothesis? Somebody's going to be able to give me the answer. Hello? What's your conclusion? What's your decision?
We reject it because it's less than.
No. The decision rule is that if Z is greater than Z star,
Oh,
you reject the null hypothesis. So let's stop guessing. You have a Z of 0.831. Is 0.831 greater than 2.576?
No.
Very good. I thought we learned something from the first example. All right. So if Z is 0.831 is greater than 2.576, would you reject the null hypothesis? Tell me the correct answer.
We do not reject that.
You do not reject the null hypothesis. Okay. You do not reject the null hypothesis. You cannot because Z of 0.831 is not greater than 2.576. So you cannot reject the null hypothesis. So what is the conclusion? Okay. That means there is no evidence that the average price of houses is greater than 450,000. As a matter of fact, the evidence indicates that the average price of housing is about 450,000, but it is not greater than 450,000. You get the point now?
Yes.
Okay.
yeah, we get it. I get it now.
You get it now? Okay.
Yeah, I see it.
Because you're going to do a lot of applications where you're going to have to make a decision, set up a problem, and solve it using these statistical procedures. All right? All right. I was going to go through doing an Excel problem, but I don't want this internet to record now because I don't even know what the recording is. But I'm going to ship this to you so that you can see it yourself. And I would like for you to summarize to yourself what you have seen this evening so that when I come back on Monday and continue to show you how to do the same problem using Excel, you have to make a choice whether you want to be going through Excel or you want to be going through SPSS. Now, at the end of this class, I'm going to give everybody a project that uses SPSS. So you really don't have much of a choice but to practice SPSS. Whether you're going to use it to do your homework assignments or you're going to use Excel, it's up to you. But I'm going to test everybody on the use of SPSS because at the end of the day, if you know where to knock, you will be in a better position to advance yourself. You get my point?
Yes, sir.
All right. So I'm going to leave it here because I'm going to also talk about how to use the T distribution and to do a problem from scratch using Excel. All right. As a matter of fact, we're going to use Excel mostly. We're going to use SPSS mostly to do the regression problem because it's much easier. I mean, you really don't have much of a choice when it comes to doing regression analysis, you're going to have to do it on SPSS because it makes more sense under the circumstances. You get that? Okay, so does anybody have any other questions about this class before I call it an evening?
Professor, you mentioned when you come back on Monday,
Yes.
do you have Zoom sessions on Mondays?
Yes, I have. The normal Zoom sessions is on Mondays.
Oh, okay.
Okay, the normal Zoom sessions are on Monday. So on Monday, I'm going to complete this lecture and then go to the next level of hypothesis testing, which is going to be testing for two populations.
Okay. Is it the same? Is this the same Zoom link on Monday?
I will send you a new Zoom link.
Appreciate it. Thank you. Thank you.
All right.
All right.
I will send you a new Zoom link. I will every week I'm going to send the Zoom link for that particular day.
Okay. Thank you. This is for Franz Henry because I have it via email.
Oh, okay. Yeah. I send it by email.
Thank you.
All right. All right. So, any other questions? All right. Hearing none, no other questions. I will say good night. I don't want to be disrupting the internet. I will say good night, and then on Monday I'll continue where I stopped, and then go to two population testing. And after that, then we'll really go into what this class is about. Not only is this class going to be about regression analysis, we're going to do multiple regression analysis, we're going to do time series regression analysis, and we're going to do index numbers. So, and that's going to start like from week 5 or week 6. So we're going to look at, a period of eight weeks or 9 weeks when you're going to really spend time on regression analysis and other topics. We're going to also do analysis of variance. So there has to, you really need to be present to understand analysis of variance. You really need to be present to understand time series analysis and the tests for autocorrelation. You need to be present to understand multi-collinearity, which is going to be a topic. And these topics are going to be very, very important. They will make a difference in your ability to compete when you go out there. You understand that?
Okay.
All right.
Thank you for the heads up.
So, I'll see you guys on Monday. And I'm going to post this. I'm going to send this by email to everybody. Actually, it's going to be on YouTube. And so you can go to YouTube and then see it all over. All right?
Okay, sir.
Okay, see you guys.
Bye.
Okay.